Hey there, Ravens. Welcome back. Time for part 5, Atomic Math. This is all of the calculations that we do having to do with atoms. All right, numbers you need to know. Atomic number is the number of protons an atom has. Every element has a fixed and unique number of protons. Remember, the atomic number is how we identify what type of element an atom is. And the periodic table is organized in ascending atomic numbers. On the periodic table, it will always be the smaller of the two numbers, and it will always be a whole number. Okay, symbol. There you go. Atomic number, atomic mass, atomic name in a typical element square. Okay, numbers to know. Mass number. Mass number is the total number of protons plus neutrons found in an atom. So atomic number is the number of protons. Mass number is where does all the mass come from? The protons and the neutrons. The same element is able to have more than one mass number. We call those isotopes. Only the number of neutrons is able to vary within an element, because as soon as you vary the number of protons, you're going to change the type of atom you have. Keep in mind, mass number is not on the periodic table. You will not find mass number on the periodic table. Atomic mass, on the other hand, is on the periodic table. It is usually a decimal, and it is the weighted average of all the known isotopes. Okay, and there we go. So on a periodic table, you're going to find atomic mass and atomic number. You will not find the mass number. Mass number is the number of protons plus neutrons. So either you have to be provided with the mass number, or you need to be provided with the number of neutrons. Then you can calculate the mass number. Okay, continuing on. Units of mass. The unit of mass is the atomic mass unit. It is the standard by which the relative masses of atoms can be compared. It originated by carbons, and so an AMU is 1/12 the mass of a carbon atom. Protons and neutrons are equal to approximately 1 AMU, and an atom's mass in AMU is equal to the number of protons plus neutrons. So mass number has a unit of AMUs. Atomic mass, which is the weighted average of all the known isotopes, is also measured in AMUs. Excuse me. Calculating particles. All right, so number of protons is the atomic number, abbreviated AN. Number of electrons will be the same as the atomic number in a neutral atom, and soon we're going to get to non-neutral atoms coming up in future units, so just keep that in mind. Mass number, Mn, is protons plus neutrons, and if you want to find neutrons, you're going to have to take the mass number minus the atomic number to get your number of neutrons. Okay, isotopes. Isotopes, same element, okay, different mass. Same number of protons, different number of neutrons. Elements can have several isotopes, and you remember that from our isotope chart where we were looking at the number of protons, number of neutrons. The number of protons is always the same, and they differ only in the number of neutrons. Isotope notation. Well, here's name form. You have your carbon is the element name with a dash followed by the mass number. So carbon 12. If I want to know how many neutrons it has, I go to the periodic table. I find out that carbon's atomic number is 6. 12 minus 6 gives me 6. That is the number of carbon atoms. That is the number of neutrons, number of neutrons in a carbon-12 atom. Here it is in symbolic form. This time it's with sulfur. Sulfur has a mass number of 32. It has an atomic number of 16. Okay, and in both of these examples, the mass, the atomic number, and the number of neutrons happen to be equal. That is not always the case. Okay, atomic number does not ever have to equal the number of neutrons, and most often doesn't. Just in these two examples. Okay, moving on. Atomic mass. This is the weighted average mass of an element's isotopes. Okay, this is what's on the periodic table. It's always a decimal on the periodic table, and it's always the calculation of all the known isotopes. The average mass of all the isotopes. And it is a weighted average based on percent abundance. Okay? It's equal to the sum of the percentages of that isotope exists in nature multiplied by the mass numbers. That's the fancy way to say it. Here's how it looks. Calculating atomic mass. Here are the directions. Change the given percentages to a decimal. You need to know percent abundance. If you're not given percent abundance, well then you're going to need to calculate it. How many atoms of that particular isotope are there out of all the atoms combined? Okay, that's kind of the math that I gave you on that worksheet, the Beanbag Lab addendum. You then multiply this decimal by the mass number for the isotope, and you add the totals up from the last step. Do not divide. Do not divide anywhere. This is a weighted average, no division necessary. Okay. Calculating atomic mass. Does it make sense? Step 4, look at it. Does it make sense, your answer? Okay. If the answer is larger than your largest mass number or smaller than your smallest mass number, something's wrong. Okay. Look at your answer. It should be close to whatever your highest percent abundance is. Okay? If you made a mistake, look, did you convert your percentages to decimals correctly? And are there any other math or calculator errors? Here's an example, see how it does it. So iron has these 5 isotopes that naturally occur. So step 1, you're going to take the decimal form, so 5% is 0.05, move that decimal over 2 places to the left, multiplied by the mass number, gives us 2.95. And basically you do that, repeat that step for all the percent abundances of all the isotopes. Okay, so just looking at this right here, 60% and 20%, okay, you can see it over here, 60 and 20, 80% of all iron atoms are 56 to 55 AMUs. So your answer is going to be somewhere in the 56 range. And if we pull ahead and look, well, sure enough, 55.95. By the way, all your decimals should add up to 100, or 1 in this case because they're all decimals, your percentages. All right, here's one for you to do. And if you want to pause here. Okay, you're back, ready for an answer. And the grand total is 24.32 AMUs. And that is where we leave today.